Welcome to Catalyst Made Up, where we ignite understanding and make learning easier. In our today's class, we'll be looking at the derivative of inverse trigonometric functions. The inverse trigonometric functions include 1. Sine inverse of x, 2. Cos inverse of x, 3. Tan inverse of x, and 4. Cot inverse of x. For the sine inverse of x, its derivative is 1 over root of 1 minus x squared. For the cos inverse of x, its derivative is minus 1 divided by the root of 1 minus x squared. For tan inverse of x, its derivative is 1 over 1 plus x squared. Whereby for the cot inverse of x, its derivative is minus 1 over 1 plus x squared. This if we are having only x. What happens in a case if you are having x is having a coefficient which is not 1? In that case, we can be using the general form, which is the sine inverse of u will now be equals to 1 all over the root of 1 minus u squared multiplied by du over dx. Cos inverse of u will be equals to minus 1 divided by the root of 1 minus u squared multiplied by du over dx. We said that the derivative of sine inverse of x is equals to 1 divided by the root of 1 minus x squared. So now let's prove this one. From the question, our y will now be equals to sine inverse of x. Next thing is that you will multiply both sides by sine. So multiplying both sides by sine, will be having sine y equals to, if you multiply sine by sine inverse, we will get 1. Then 1 times x will give us x. So our sine y will now be equals to x. Next thing is you will differentiate both sides in respect to x. So you will be having d of sine y all over dx will now be equals to d of x all over dx. Implicitly, if you differentiate sine y, we will be having cos y dot dy dx. Because we say anywhere you differentiate y, you will put dy dx, which will now be equals to, if you differentiate x, we'll be having 1. So from here, we'll make our dy dx subject to the formula by dividing both sides by cos y. So our dy dx is now equals to 1 divided by cos y. Looking for the identity of cos y, let's remember our trig identity. We know that sine square y plus cos square y is equals to 1. We'll make our cos square subject to the formula. We'll be having cos square y will now be equals to 1 minus sine square y. Remember, it's cos y we're having, while here we're having cos square y. We'll square both sides so that we'll be having cos y. Squaring both sides, you'll be having cos y will now be equals to the root of 1 minus sine square y. Now, substituting it back to this function will now be equals to 1 divided by the root of our cos y is now 1 minus sine square y. So we'll be having 1 minus sine square y. Remember, our sine square y is the same thing as x. So we'll be having 1 over root of 1 minus x. Since it is square, we'll be having 1 minus x squared. So this is how they get the derivative of sine inverse of x as 1 divided by root of 1 minus x squared. Moving on to the cos. Cos inverse of x is minus 1 over root of 1 minus x squared. Now let's prove this one too as well. Our y is equals to cos inverse of x. Multiply both sides by cos. We'll be having cos y equals to cos multiplied by cos inverse will give us 1. 1 multiplied by x will be having x. Next is you will differentiate both sides with respect to x. So you will be having d of cos y all over dx equals to d of x over dx. Implicitly, if you differentiate cos y, we will be having minus sine y dy dx, because anywhere we differentiate y, we put dy dx in implicit differentiation, which will now be equals to, if you differentiate x, you will be having 1. So from here, we will make our dy dx order to the formula by dividing both sides by minus sine y. So our dy dx will now be equals to 1 divided by minus sine y. So we'll be having dy dx will now be equals to minus 1 divided by sine y. Using trig identity as well, our sine square y plus cos square y equals to 1. Make sine square y solution of the formula. Sine square y will now be equals to 1 minus cos square y. From here, we'll make our sine is sine y we are looking for, but it's sine square y that we get. So next thing now is you square both sides. We'll be having sine y will now be equals to the root of 1 minus cos square y. Substituting it back to this function, we'll now be having minus 1 divided by our sine y is root of 1 minus cos square y. So we'll be having divided by root of 1 minus cos square y. Remember, our cos y is the same thing as x. So we are substituting cos y with x. We'll now be having minus 1 divided by the root of 1 minus x. Here is square we are having. So we'll be having 1 minus x squared. So this is how they get the derivative of cos inverse of x. The last one we shall be talking on this video is tan inverse of x. Tan inverse of x. We said the derivative of tan inverse of x is 1 divided by 1 plus x squared. Now let's prove it. Our y equals to tan inverse of x. We'll multiply both sides by tan. So you'll be having tan y equals to tan multiplied by tan inverse will get 1. 1 multiplied by x will be having x. Next thing is differentiate both sides in respect to x. So we'll be having, if you differentiate tan y, we'll be having sec square y dy dx, because anywhere we differentiate y, we'll put dy dx, which will now be equals to, if you differentiate x, we'll get 1. So from here, we are looking for, we will make our dy dx out of the formula by dividing both sides by sec square y. So our dy dx will now be equals to 1 divided by sec square y. Then going to the trig identity, we know that sine square y plus cos square y equals to 1. We'll divide through by cos square y. So from here, divided by sine square y divided by cos square y divided by cos square y, then 1 divided by cos square y. And we know that sine square y divided by cos square y will give us tan square y, because sine all over cos will give us tan. Then plus cos square y divided by cos square y will give us 1, which will now be equals to 1 divided by cos will give us sec. So we'll be having sec square y. Remember here is our sec square y that we are having. So we must bring everything of the sec square y into this function. So it will now be equals to 1 divided by our sec square y is the same thing as tan square y plus 1. And we said our tan y is the same thing as x. So substituting tan y with x will now be having 1 divided by x plus 1. Our tan here is carrying square, so the x here will also be carrying square. So this is how they get the derivative of tan inverse of x. Let's solve this question. The so we should differentiate the following with respect to x. The first question here is y equals to sine inverse of 3x. Using the identity for the sine inverse, we said that if you are having sine inverse of u is the same thing as 1 divided by the root of 1 minus u square multiplied by du dx. So in this case, our u here is our 3x. So our u is now equals to 3x. Now, for us to get du dx, we have to differentiate u in respect to x. So you'll be having du dx will now be equals to, if you differentiate 3x, we'll be having 3. Then substituting everything back to this function, our sine inverse of 3x will now be equals to 1 divided by the root of 1 minus our u is 3x. So we are having 1 minus 3x squared, then multiply by our du dx, and our du dx is 3 multiplied by 3. So we will be having 1 multiplied by 3, we will be having 3 divided by the root of 1 minus 3x square will give us 3 square and x square. 3 square is 9. 1 minus 9 x square. So this is the derivative of sine inverse of 3x. The second question is y equals to tan inverse of x square plus 1. The identity of tan u is tan inverse of u is equal to 1 all over 1 plus u square multiplied by du dx. In this case now, our u is x square plus 1. Therefore, our u is now x square plus 1. Then we will look for du dx. For us to get du dx, we will differentiate u to respect to x. So we'll be having du dx is now equals to, if you differentiate x square plus 1, we'll be having 2x. So from here, we'll substitute everything back to the identity of tan inverse of u. So from here, our tan inverse of x squared plus 1 will now be equals to 1 divided by 1 plus our u is already x squared plus 1 all squared, then multiply by our du dx, which is 2x. So from here, we'll be having 1 multiplied by 2x will give us 2x divided by 1 plus x squared plus 1 all squared. Question 3 is y equals to cos inverse of 2x minus 1. Using the identity of cos inverse of u. Cos inverse of u is equals to minus 1 all over root of 1 minus u square multiplied by du over dx. From here, our u is 2x minus 1. So we'll be having u equals to 2x minus 1. Differentiate u in respect to x. You'll be having du dx will now be equals to 2x minus 1 will give us 2. So substituting everything back to the identity, you'll be having the cos inverse of 2x minus 1 will now be equals to minus 1 divided by the root of 1 minus, here we're having u square but our u is 2x minus 1. So we'll be having 2x minus 1 all square multiplied by our du dx, which is 2. So minus 1 times 2 will be having minus 2 all divided by the root of 1 minus 2x minus 1 squared. So this is the derivative of cos inverse of 2x. Question 4 is cos inverse of x cubed. Using the cos inverse of x cubed. Go. Now, using the identity of cos u, which is cos u, okay, using the identity of cos inverse of u, cos inverse of u is equals to minus 1 divided by the root of 1 minus u squared multiplied by du over dx. So from here, our u is x cubed from the question. Then we'll look for du dx by differentiating u in respect to x. So our du dx will now be equals to if you differentiate x cubed, you'll be having 3x squared. Substituting it back to the identity, our cos inverse of x cubed will now be equals to 1 divided by root of 1 minus u squared, and our u is x cubed. So we'll be having 1 minus x cubed all squared multiplied by du dx, and our du dx is 3x squared. So from here, 1 multiplied by 3x squared will be having 3x squared divided by the root of 1 minus x raised to the power of 6. Question 5 is y equals to sine inverse of root 3x. Now get your paper, pen and calculator, solve this question and leave your answer in the comment section. Kindly subscribe, like, comment and share. Don't forget to turn on your notification bell so that you don't miss any new video.